Our last video is about inheritance. Inheritance allows a class to inherit attributes from another class. We'll look at the definition on the screen in a moment. First, I want to take us back to the myClass class that we've been building and simplify it down to something we had done earlier, which is you initialize a class or a myClass instance with a name. Anytime you construct this instance, a init will get called. Here's the name that we passed. We're setting that name as an attribute in the class, and then it's possible for us to call greet to say hello to the user. y.greet. Great. And so now it should say, hi, David. But I'd like to show you a mechanism that makes it possible for this class to extend its functionality. By making use of another class. I'm going to begin by asking you what we're likely to see if I call a method called analyze on this instance. The first thing we want to do is ask, well, if you call analyze, what are you actually doing? And the answer to that is you're actually looking up an attribute. As we saw earlier, we have something called attribute lookup. And when Python tries to look up an attribute, it's going to look first where? Do you know? The place where Python looks for an attribute first is in the instance itself. This is for objects. In the instance itself. And if it can't find it there, where is it going to look? It's going to look in the class. So when we say y.greet, Python will look for greet in the instance, but it doesn't find it there because the instance only has one attribute, name. It then looks in the class. So when we say y.greet, it's going to call greet, and we'll see the message printed. But when we see y.analyze, what's going to happen? Well, again, Python's going to look in the instance and then in the class, and if it can't find it in the class, it's going to give us an attribute error. This attribute error is very similar to the idea of a name error or a key error. Remember what a name error means? A name error means I can't find that name in the variables that you created. And a key error means I can't find that key in the variable that you created. But this means I can't find that attribute in the variable that you created. This y doesn't seem to have access to any attribute. In other words, it's not in the instance itself, and it's also not in the class. But I can get this to work by inheriting this class from another class. And I think it's called name analyzer. It's right above here, and I'm now going to show you that this works. And the reason it works, and by the way, the name analyzer will analyze the string and say it has 5 characters with 2 occurrences of D in it. This name analyzer is not part of the class, but my class inherits from it. And so if we look above, and the class doesn't need to be above, but it happens to be, we see that name analyzer has a method called analyze. And so by inheriting from name analyzer, we're able to access the analyze method. I wanted to do this again with Agamemnon so you can see. Because that's got a lot of repetitions. Let's see. Okay. Looks like Agamemnon has 2 occurrences. It has 9 characters, 2 occurrences of A, of M, and of N. Interesting. You could take a look at this method if you're curious to see how it works. This, by the way, is something called a dict comprehension, but we're not going to go into that. The main idea of inheritance is that we can break up functionality, especially shared functionality that might be taken advantage of by multiple classes through this inheritance scheme. Inheritance means that a class is able to inherit the attributes from another class. We call it a parent-child relationship, meaning that name analyzer in this case is the parent, and name or my class is the child. But really what we're looking at in inheritance is an extension of the attribute lookup. Remember, just a moment ago we said that when we say y.analyze, where's the first place that Python looks for the attribute? It looks in the instance itself, in y. But as we said, y only has one attribute, its name. The next place that Python looks for the attribute analyze is in the class, but it doesn't find it there either. So then, because we've had my class inherit from name analyzer, Python has a third place to look. It's going to look in the parent class and look for that analyze attribute, which is a class attribute or a class variable, in that class. And in this case, it finds it. So we're able to share functionality between classes by using this inheritance. Now again, this is a more advanced feature of object-oriented programming, but it's an important one to know. And in fact, it's going to come into play a lot more strongly next week when we look at our ability to inherit from any kind of class. Any class can inherit from any other class. And again, that means that it inherits the attributes of that class. The simplest way to think of it is to think of it as a way of, as an extension of the attribute lookup. In the first case, analyze being looked up in the instance, and then in the class, and finally in the parent class. And that is the meaning of inheritance. Now again, it's really kind of hard to see exactly why this is so powerful. But if you can imagine that a larger system that's written in object-oriented style can make use of multiple kinds of inheritance or inheritance from multiple different parent classes that may actually inherit from each other and inherit up into, an ancestor relationship that goes up 3 or 4 levels, you may begin to see that it's possible to create a class that can extend its functionality really broadly by inheriting from multiple classes, which is possible in Python. So this is the meaning of inheritance. And it's something just to keep in mind as we continue to explore object-oriented programming and as we continue to use it.